dear listeners and presenters also behind our screens. I'm pleased to welcome you to our second webinar. My name is Ada Trauman and I'm a moderator of today's event. And who participated in our previous webinar, we already knows that this kind of series of webinars are organized according our European Conference of Protective Clothing. It will take part next year in May in Estonia, in Tallinn, 11 until 14 of May. So welcome to our conference. And also we are hosting 14th International Manikin and Modelling join with our conference on the third day. But today I'm pleased to welcome our presenters. Our webinar's topic is today inclusive fire protective clothing. And we have three presenters here. So welcome.
Good morning, everybody. My name is Jemma Forgie. I'm a PhD candidate at the University of Alberta. And today I'm going to be talking about a study that we are working on called Fit Issues and Opportunities in Women's Fire Protective Clothing. So this research was done in collaboration with my supervisor, Dr. Patricia Dolas, here at the Department of Human Ecology at the University of Alberta. So I've created a brief introduction, which I'm sure we will get a little bit more depth on from Josephine and Jackqee. But essentially here we're looking at fire protective clothing, which is vital to keep firefighters safe from thermal, physical, mechanical, chemical, and biological hazards. So there's a variety of components. Covering the majority of the body is the turnout coat and the turnout pants. In addition to that, we also have turnout boots, fire-resistant gloves, a helmet, a hood, and a self-contained breathing apparatus, which sits in a backpack. So in order to get protected by this protective clothing, we need to look at not only the material performance, but also the fit. So poor fit of fire protective clothing can result in decreased protection and mobility, which can lead to injuries. This is particularly a concern for female firefighters. The most recent statistic we have is from 2016, and here it was stated that 80% of women reported wearing ill-fitting fire protective clothing and equipment. So this statistic was coming out of the United States. But in general, we see an overall lack of availability of gender-specific protective clothing and equipment, with women experiencing issues of ill-fitted fire protective clothing at approximately 4 times the rate of men. So there's several problematic elements, including the garment length, the pocket placement, suspender placement, and waist to hip ratio. As well, we see issues with glove and boot sizing, where the size ranges are not inclusive enough for many women in the field. And we also see the issue of poorly fitted SCBA face masks. So in order to solve these issues, there's a few solutions that women can go through without needing to have an entire ensemble redesigned. So the first thing that they can do is ask their station to get new equipment. So this typically involves a lot of lobbying in order to get better fitting fire protective clothing. The issue with this is that it's often not in budget. So these turnout ensembles tend to be very expensive. And there's also underlying concerns of gender discrimination. So if you're the only woman or one of very few women in the field, it may not feel comfortable to speak up to your station. The second option would be for these female firefighters to pay out of pocket and source equipment that has a better fit. This is usually only feasible for smaller elements of gear. So for example, the gloves or sometimes the boots. As I mentioned before, turnout gear tends to be very expensive. And the third option here, which is what we're really investigating in this study, is looking at this idea of making do. So here we're looking at what women can do with what they already have. So are they able to modify or alter their fire protective clothing in a way that helps them to improve safety, comfort, and fit? So this is often the most available cost-wise. However, we don't have a lot of data on the types of modifications actually being done by female firefighters, so this is where our study comes into play. So in terms of our research objectives, the first thing that we were looking at was identifying the frequency and types of modifications that were performed on fire protective clothing by female firefighters in Canada and the United States. Next, we were looking at understanding the perceived efficacy of these modifications on the fit, function, and safety. And finally, we want to provide recommendations for modifications on fire protective clothing for female firefighters. So in order to achieve this, we have done two methods. So the first one was a survey. This was an online survey that was distributed in Qualtrics, and it was given to female structural firefighters across Canada and the United States. It had a mix of open-ended and multiple choice questions with 5 sections. So firstly, looking at demographic information of the female firefighters, so looking at how long they had been in the fire service, what type of firefighting they were doing, and where they were. Next, we looked at turnout gear information. So here we were really interested in how the turnout gear as first received was fitting. Looking at fit of existing garments, again, looking at that fit process. Then looking at modifications, so any changes that had been made to the fire protective clothing. And then finally, efficacy of modification. So evaluating if women had modified their gear, how effective those modifications had been at improving the fit, function, and safety of the gear. Next, we did a series of interviews. So these were qualitative, semi-structured interviews. I wanted to note here that we did do a series of interviews before developing the survey in order to get ideas on language phrasing and important questions to include in the survey. But here the results I'll be sharing are from our follow-up interviews that we conducted after the survey. So at the end of the survey, we had an optional question for participants to leave their contact information if they were interested in being followed up with to discuss more about their survey responses. And the objective here was really just to collect more in-depth data on fit issues and the efficacy of different modifications shared. So moving on to our results, in our survey, we had 379 participants post-screening with diverse locations across Canada and the United States. However, majority of our participants were Canadian in this study. We had a good split of career and volunteer firefighters with approximately 70% career firefighters and 22% volunteer. And in our interview, we had a total of 14 participants for the follow-up portion of the interviews. Again, diverse locations throughout Canada and the US, but with a focus specifically on Canadian firefighters. And we had 12 career firefighters and 2 volunteer firefighters, so kind of a similar ratio to what we saw in the survey. First, we looked at the fit of current turnout gear. So this is the section of the survey that gives background information about the turnout gear when it was first received. So we had a baseline question asking women whether they felt it was important to have well-fitted turnout gear, and 92% said it was extremely important to wear properly fitted turnout gear. So majority of our participants understood the nature of turnout gear and how it protects them from the different hazards they face on the job. 58% of participants said that their turnout gear fit too large, and also a big chunk of participants said that their gear fit too small. So only 23%, less than a quarter, rated their fit as being just right. Additionally, we saw that 78% of participants rated their turnout gear as being bulky. So this was anywhere from somewhat bulky, bulky to extremely bulky. Next, we saw that 57% of female firefighters rated ease of movement as somewhat difficult. So in addition to the gear being too large or too small and also bulky, a lot of women said that it was difficult to move in this gear, which is essential for their work. And we saw the highest rates of dissatisfaction with the gloves, the pant crotch, the pant hip, the helmet, and the SCBA. So we will be going more in depth into these different issues, but this is a pretty consistent trend with what we have seen in the literature coming out of the United States, looking at different fit issues for female firefighters. So the next thing that we looked at was the sizing process, and specifically for custom gear. So here we're defining custom gear as gear that firefighters have been measured into by gear reps. So typically what's happening is gear reps are coming to the station, they're taking a few measurements of the firefighters, and then these measurements are matched with the best fitting gear. In terms of the custom portion, typically not an entire new pattern is drafted, but instead we'll be making small adjustments such as changing the sleeve length, pant length, or coat length. But it generally is not indicating women's specific fire protective clothing. So we saw in our survey that the majority of firefighters, about 58%, received custom gear for their first set, whereas communal gear was slightly more common for their second set. Generally, when we compare custom gear with communal gear, which would be gear that's just sourced from what's already in the station, custom gear is considered a better option because there is the ability to match people to the best fitting size based on their measurements and also make these small adjustments to better fit the wearer. But our results indicated that custom gear was not always well fitted to the wearer, and in a lot of cases, women would actually opt to try on different communal gear, so gear that they already had in the station, as opposed to wearing the custom gear that they had been issued. So some of the challenges that we saw, first of all, that the custom gear did not necessarily indicate gender-specific gear. So we saw that 86% of survey participants did not have access to women-specific fire protective clothing. And of those who did have access, only about half of them were actually using women's fire protective clothing, indicating that there may have been other fit issues. Another issue that we saw was that inaccurate measurements were taken. So in our follow-up interviews, it was uncovered that direct measurements from the gear reps who came to measure the firefighters did not always result in gear that fit. One reason for this could be about the assumptions from the fire protective clothing reps. So sometimes the people measuring the firefighters would make assumptions about what women wanted or needed. So for example, some participants indicated that the gear reps were really insistent that they sized up to accommodate for the weight gain over the 10 years that they would be keeping this fire protective clothing. But in most cases, this resulted in gear that was much too big. Another assumption that was made was sometimes the gear proportions would be changed without consulting the participants or their measurements. So a few participants indicated that the manufacturers had added flare to the turnout coats, which resulted in a coat that was tight at the shoulders and kind of wide at the hips, even though this may not have reflected their actual body proportions. Simply because they were women, they were adding this kind of flare to the coat. And then in terms of other factors, one participant mentioned that she felt the PPE specialist was quite uncomfortable with taking her measurements because she was one of very few women. And so just having somebody kind of get up close and personal, she felt as though her measurements were taken inaccurately. And then another participant had mentioned that during COVID was when she was fitted into her gear, and so they had to use virtual laser fitting, which resulted in poorly fitted gear. But then that gear still had to be kept for the next 10 years. In terms of fit issues and modifications, we're going to address the different components of turnout gear separately. So starting with the coat here, the turnout coat was one of the better fitting elements of the gear. So we saw about a 60% rate of satisfaction with the sleeve length and armhole width. but less than 45% satisfaction with the chest, shoulders, coat length, and pockets. And we did see that there was some modifications done to the coat, so about 13% of participants reported modifying their coat. Some areas for improvement of the turnout coat included the bust and shoulders. So here we're thinking about a coat that's really been drafted for somebody who may have a flat chest or no chest at all. So wider busts were not accounted for in this unisex sizing. And so women had to essentially make a choice between wearing a coat that fits in the bust but is too large in the shoulders and elsewhere in the coat, or sizing down to a coat that is tight in the bust but fits in the shoulders. For this area, there were no modifications suggested. It was kind of just said that there would have to be a choice between these two. Next, a lot of women indicated issues with the coat pockets on the turnout coat. So many said that these pockets were inaccessible when wearing their SCBA pack over top. Some other participants said the pockets were too large. So when the pattern was scaled down to fit kind of a smaller frame, the pockets were often not scaled proportionally so that all of the gear could still fit, but this resulted in the pockets being quite difficult to access. And there was also mentions of the pockets getting caught on things when moving, which is not ideal when you're trying to move quickly in an emergency situation. In terms of modifications for the coat pockets, we saw women avoid storing gear in their pockets and then also create smaller teams so that they could carry less gear individually and kind of work together. Again, not ideal in case of separation from the group. And then also putting gear in pants pockets. So a lot of women just avoided putting gear in their pockets altogether because they were quite inaccessible. In terms of the coat hips, which is our last area here, we saw that the coat hips again were either too tight or too loose. So again, this jacket is really designed for a more rectangular figure. So in terms of modifications for the coat hips, if the coat hips were too loose, women would add extra layers underneath. So for example, some women mentioned that adding their harness bag underneath helped to kind of bulk it out a little bit. And then other women mentioned adding belts or sweaters or other kind of extra clothing under the turnout gear in order to help with the excess room at the bottom of the coat. If the hips were found to be too tight, participants would leave their coat open or unzipped or pull it up to their waist to do it up. Again, not ideal because this is generally limiting range of motion, and without fully sealing the coat, we are compromising the thermal insulation that can be provided by the turnout gear. The pants were a little bit more problematic in terms of fit issues compared to the coat. So about 40%, less than 40% rate of satisfaction with the pant waist and leg width. And we did find that 15% reported modifying their pants. So generally the issues here, first of all, were the pant hips. So we saw less than 30% rate of satisfaction with the pant hip and crotch. So the tightness at the hips made the pants very difficult to move in, and this was one of the most common fit issues found among survey participants. The main modification here was just to change what was being worn underneath the turnout gear. So typically we would assume that station uniform, so just a pair of fire-resistant pants would be worn underneath the turnout pants. But generally when there was tightness in the hips, women reported wearing men's boxer briefs, shorts, or leggings underneath their fire protective clothing, which tended to not be FR or made of natural materials. So that is a little bit of a concern with synthetics being exposed to high temperatures. Next, we saw some fit issues with the pant waist. So here the waist was too loose when the pants were fitting in the hips. So modifications included wearing a belt with the station uniform underneath the pants, also adding an aftermarket belt to the pants in order to kind of cinch it and make it tighter around the waist. Some women also reported using a carabiner to kind of join together belt loops, which helped to tighten the waist. And then also there was a lot of reliance on suspenders in order to keep the pants from falling down. Finally, we saw issues with the pant leg width. So in this case, it was either too wide, which caused excess bulk, or too tight, which limited movement. And again, here there was no modification suggested. Finally, looking at the different elements of the gear, so beyond just the coat and pants, we're thinking about the helmet, gloves, and a CBA pack. This is where we saw a very, very low rate of satisfaction, so less than 30% rate of satisfaction, and a very high rate of modification. So we saw that 26% of firefighters reported modifying their gear, making this the most modified aspect of the turnout ensemble in the survey. So the first issue that we saw was with the gloves. So gloves are provided with standard sizing, so there is not really options for customizations here. But a lot of women reported that they had to make a choice between a glove that fit in the palm but was too short in the fingers, or gloves that fit in the fingers but were too wide in the palm. So this is a common challenge that, again, has been documented in the research before. But essentially, the current sizing schema of gloves does not accommodate for the proportions of a lot of women's hands. So modifications here were to firstly avoid wearing fire gloves altogether, or substitute them with a different type of glove. So some of the gloves women mentioned in follow-up interviews included EMS gloves, extrication gloves, hexoskin gloves, and general leather work gloves. A lot of participants were not aware whether the gloves they were wearing were actually fire resistant, though. Next, in terms of the helmet, even with adjustability of the inner harness of the helmet, the outer shell of it was still bulky and would interfere with women's hair as well as the SCBA tank. So one woman mentioned that when using her gear for high-rise fires, she was not able to wear her helmet as it completely restricted her vision. And there was lots of other women who had mentioned this kind of restricted vision with wearing a helmet. So modifications here included wearing a toque or bandana underneath the helmet to add excess bulk, or add aftermarket padding, or finally just remove it altogether, which again creates a big issue in terms of safety. Next, in terms of the SCBA packs, so the main difficulty here was that this can knock the helmet out of place. So these images were provided to me by a participant, and you can see in the first image here that the SCBA tank is actually hitting the brim of the helmet. So essentially, if any head motion were to occur, the helmet would be knocked out of place, potentially interfering with the vision. In this case, the firefighters were able to lobby for an adjustable oxygen tank, so it was able to move up and down the back, which was more accommodating for shorter firefighters. Some other difficulties with the SCBA pack was that it was difficult to place the backpack itself on the body. So the straps would be maxed out, but it was still too big, making it difficult to distribute the weight of the tank, resulting in soreness in the upper traps and shoulders. No modifications were mentioned for this in the interview, but there is better options, for example, with this adjustable oxygen tank. And then finally, we saw issues with the SCBA mask. So some participants mentioned that even with the different sizes of masks available, they weren't able to pass a fit test with any of these sizes. So when asking a fire rep what to do when one woman failed all series of the fit test, they recommended to not enter a fire, which of course is not realistic for a firefighter. So the modification we saw here was adding an adhesive foam around the edges of the mask to create a seal. However, it's unlikely that the foam here was fire resistant. So some conclusions from this study: we found that female firefighters are continuing to face difficulties in finding appropriately fitted fire protective clothing, even with the rise of custom sizing. Modifications serve to improve ill-fitted gear in the moment, but most solutions were temporary and insufficient to meet the long-term needs of female firefighters. And sharing this information about the shortcomings and modifications of gear with fire departments, fire protective clothing manufacturers is critical to improve gender inclusivity in fire protective clothing. I would like to thank everybody who has helped with the development of the survey, recruitment of participants, and just ideation of this study in general. And also thank all of our funding partners who helped with this study. And then finally, we just wanted to mention that there is a special journal issue currently being produced on inclusive PPE. So this is done through the Journal of Engineered Fibers and Fabrics. So we encourage everybody who's interested to reach out to Dr. Patricia Dolas or Dr. Meredith McQuarrie or submit here with the link on the screen. Thank you very much.
Thank you very much, Jemma. So we received some questions as well, but I would like to remind that we will do it at the end. So questions and answering forum. So I will give the word for our next presenters, Josephine and Jackqee.
Good morning, everyone. My name is Josephine, and I'm presenting alongside Jackqee. Jackqee and I are postdocs on our research team here in the United States, and we'll be presenting on inclusive female fire protective clothing and talking about just how far we've come in our studies and what we've seen so far. So at the beginning of the study, which was back in 2019 before we joined the team, initial feedback was gathered from PPE manufacturers and firefighters, coupled with existing literature reviews to better understand why the gap still exists in ill-fitting and poor sizing, a lot of which Jemma has described. The findings allowed our group to create a path for possible solution with the ultimate goal to design and develop firefighting protective clothing that is suited to female firefighters in the United States. Since then, the project has been awarded over $2 million in funding and has allowed the team to establish an initial female firefighter anthropometric database, design and develop the first prototype that were tested using fit function protocol last summer, and findings from those have now been put back into production, and we hope to test the second iteration in the coming summer. So that's exciting for us. We've also analyzed that data by comparing our anthropometric database to standard sizing and to the general female population suited to the United States as well. And so today we'll be presenting on some of the important body measures in our data pool. So we have a lot of data points, but we're just gonna, streamline to a few. Okay, Jackqee.
Yeah.
So very briefly, these are some of the problems on the background study. They are faced with the same dangerous conditions. However, the women are 33% higher at risk. This does signify a critical problem that requires immediate attention. A lot of it has been attributed to ill-fitting gear. And, 80% of female firefighters self-report poor fits. This suggests very high dissatisfaction. Women's sizes are not readily available. Even in situations where they are available, they're not made from a female pattern. And so it goes back to what's the shape, how are women shaped in the first place. And we know that from literature, differences does exist between the male and the female anatomy. Okay, a lot of offering of downscaling has been suggested, but we know that women are not just simply smaller version of men. It's not true, so it's not effective. In terms of the methodology focused on the data that we're presenting today, our data collection has been through remote scanning app and stationary body scanning apps, which gives us over 240 plus measurements. Data analysis includes descriptive statistics, interpretive thematic coding, as well as some correlational analysis, ANOVAs and t-tests, just to help us better understand the data. And so in today's presentation, we are looking at measuring the suitability of our sample to the NFPA 1977 and 1971 sizing standard and the general female population, which is collected by iSize America. Again, right now, 1977 is now 1950 and 1971 is now 1970. However, this data was collected prior to those changes in prior to those changes that were made. So we'll start with the 1977 standard sizing. We looked at the sleeve length. I'll take a few minutes to just describe the graphs because we'll see a couple of them. So in the graph at the top, data points in green in between the two blue lines indicate body measures in our sample data that fall within the standard sizing system. Okay, so in the NFPA 1977, there is the standard sizing system for different parts of the body, what the lower should be and what the higher should be. And so in our data points, those in green are those that fell within that. Below that, in the lower limit here in purple are those that fell outside of it, but in the lower limit. And when you see data points here, those are those that fall outside, but in the upper limit. Okay, so they do not fall within the NFPA range. Here, this is female fire distribution data over a histogram. So the green portion is the estimated coverage. So we're able to see how much coverage does this actually have in percentage when looking at the full population, the full estimated population. So we'll see a couple of these graphs as we go. So as we see from the top graph, 49% has sleeve length shorter than the minimum standard sizing requirement. This means that those that do not fall within the standard requirements or guidelines that have been provided by the NFPA do not have a way to do not have sleeves that fall within that. And so that could be challenging because then you have this wearing sleeves that are too long, right? In terms of sizing system, looking at the graph below, only about 44.6% is covered. And that's low, it's below 50%. So looking at our sample size, which is an initial data of 187, more than half of them, only less than half of them are being covered. This aligns with previous qualitative studies on sleeve length dissatisfaction reported by female firefighters. So there's been a lot of qualitative studies previously, had people complain about dissatisfaction, the sleeve doesn't work, but now we're able to actually put that into numbers and to see them. So that's really great. We also looked at the waist circumference. For the waist and the next three measurements that we'll see, changes were made. So we collected and analyzed our data between 2021 and early 2022 before the 2022 edition of the sizing standard was released. And so it was important for us to see if those changes actually made a difference, right? So that's what we had. That's why we have two graphs here. We have for the 2016 and for the 2022. So we can see that even between both graphs, there was difference, but there was no much difference. Okay, 75% of participants exceeded the waist circumference given in the NFPA standard sizing, suggesting that we have people with larger waists, people are more on the bigger size than what the sizing standard is accommodating. The revisions in 2022, even if there was increased by 5.1 centimeter addition in both the lower and the upper limit, it increased the overall proportion from 28 to about 46%. So it did make a change, but not enough change that I would love to see. And then studies on women's weight gain, particularly midlife between 30 to 50 years, which is the age range between most firefighters, show that they experience steady weight gain, particularly in the arms and around the midsection. So this is definitely needs a revision, okay? This definitely needs to change in terms of waist. And so that's why people feel very uncomfortable around there and then complicated with when you put on the SCB and things like that. Next slide. Okay, so this is one of the worst results that we saw in terms of the front rise. The NFPA 1977 front rise ranges was adjusted from 11.1 to 18.1 in the 2016 edition. And in the 2022 edition, it was 8.6 to 15.6. So the lower limit was reduced and the upper limit was also reduced. And we don't even know the basis for which these changes were made in the first place. But we did see that it worsened the situation. It didn't make it any better in terms of coverage. It amounted to about 0% coverage. So that's just meaning that even when these changes, we were calling for changes, yes, but when those changes are made, they have to follow the anthropometrics of those who are going to be wearing this clothing. So we can see the discrepancy between what is in the standards and what's in the actual body measures that we have. We also looked at the back rise. So the back rise range was from 25 to about 31 in the 2016 edition, and that got reduced to 23.8 and from 23.8 to 30.8 in the 2022 edition. The adjustment slightly increased the percentage of participants falling within the size range from about 69% to 73%. However, more than a quarter of the sample, so about over 26.7%, that's about 50 of the participants still had back rise measurements that fell outside the specified range. While the 2022 changes improved the overlap proportion, made it a bit better, shorter back rises, further revisions are needed to fully cover the diverse back rise measurements of the female firefighter population. Because this has to do, the challenges is all, or when you have people, whether it's the sleeve length or moving outside or below, it's always a question of fabric. So if it's shorter, there's nothing you can actually do because you need extra fabric. Your skin becomes exposed, and that's more skin burns, more dermal inhalation of smoke and all those cancerous smoke. And then if you have extra fabrics, then you have too much fabric. Okay, so are you folding? Are you using how are you holding up the excess fabric that you have in different places? So it's always the flip side of it. So do you have shorter fabric? Do you have extra fabric? And what do people do with those when they have them? And how does that impact, the efficiency of the job? So we then looked at NFPA 1971 standard, which looks pretty good, pretty good. So if you look at the chest circumference, the sleeve circumference, we have a lot of the participants that fall within the sizing range. It seems to work, even though at the end of the day, we still want everybody to be well fitted. You want everybody to nobody should be left behind. Realistically, that those who have to be really custom fitted, yes. So this looks good. However, analysis is limited to just 4 measures in the standard. So you have just the chest and the sleeve for the upper, and then you have the wrist and the inseam as well. So when you think about clothing construction, like 4 measures is not enough. Still very far off, from what is needed. So in terms of the main takeaways, wildland sizing system wildland sizing system is garment-based as opposed to body measures. That also creates a layer of problem because when you're converting from body measures to clothing measures, how much ease should you put and how should that be determined? All of these intricacies can end up creating faults or inaccuracies in the final garment. So that's something to put in mind, is that the wildland sizing system is based on garment, not on body measures. Okay, and when we measure, we do on the body. In terms of structure, there's a narrow scope of the sizing system. It is insufficient to address the female firefighter sizing and fitting challenges that we have. So again, these are just very few measures that we've picked. We have 240 measurements. Our PIs, Dr. McQuarrie and Dr. So we have a lot of work to do, still piecing up all the data together. So I'll hand it over to Jackqee.
In the study, we also compared the anthropometric data of the U.S. female firefighter with the general female population. Regarding the 2 sample group, the first group we use is formed by 187 U.S. female firefighter, and the data is collected remotely by using the Me360 app scanner by size string. And the second group has 4,632 women from the general population. And this data is sourced from the Size North America survey, and it's collected using the VITA stationary body scanner. We compared the two primary body measurements and 11 secondary body measurements to get a comprehensive picture of the comparison. The primary measurements we select include height and the bust, because these 2 measurements are foundational in size chart development, and they are frequently used to categorize the body types and determine the clothing sizes. The secondary measurements are the circumference of waist, hip, thigh, knee, neck, and the wrist, and the total arm length, inseam, front crunch length, and the center back waist length. So these measurements are the ones that we screen out based on the measurement availability of the two data pools. These measurements help us understand how the sizing of the current PPE needs to be adjusted for the female firefighters. We found that for the height comparison, female firefighters on average measured were about 6 centimeters taller than their counterparts in the general female population. This difference is significant, and this highlights the need of considering height in designing the protective gear for the female firefighters. The bust measurements of female firefighters closely match the general female population. We can see both the mean and the median values are roughly the same, and no significant difference is found between the two groups. However, the range of the bust size among the female firefighters was much narrower. It is from 85 centimeter to 141 centimeter. This narrower range suggests less variability in the bust size among the female firefighters compared to the general population. But this could be due to our smaller sample size, so more data will be needed to verify this result. Regarding the secondary measurements, the analysis revealed that there are significant difference in waist, hip, knee, ankle, collar circumference, wrist, and the leg inseam length, front crunch length, and the center back waist length. However, there was no significant difference in the thigh circumference and the total arm length. For the waist, the female firefighters had significantly larger waists than the general population. The average difference is about 10 centimeter. When we compare this, combine this with the bust circumference results, we can see that the female firefighters in our study tend to have a straighter upper body shape compared to the general population. And when we look at the lower body dimensions, the female firefighters have slightly larger hips. The difference is about 3 to 5 centimeter. And hip measurement also showed a much narrower range. This varied between 97 centimeter and 118 centimeter. This also suggests less variability in the hip size within the female firefighter group. And female firefighters were also observed to have larger neck and wrist circumference compared to the general population. And the difference in neck circumference was about 1.3 centimeter. And the female firefighters were also found to have a longer front crunch length compared to the general population. And the range for the front crunch length is narrower, which indicates less variability as well. For the length measurement comparison, it is important to know that although the female firefighters generally have longer measurements, one exception was the total arm length. The female firefighter group in our study had measurements that were comparable to the general U.S. female population. So this suggests the total arm length might not require separate consideration for sizing adjustment in female firefighter protective gear if the initial sizing is based on the general female population. Moving forward from the descriptive analysis, we further visualize the correlation and distribution in the 2D scatter plots. So we visualize the relationships between the bust and height, bust and waist, bust and hip and waist. We can see in each figure, there are 6 straight lines. So they are representing the P5, P50, and P95 of the corresponding body measurements of the general population. In figure A, we can see this graph visualize the distribution of the bust and the height for us to see the coverage difference between the two data pools. The female firefighters are generally taller, while their bust circumference align more closely with the general population. And the female firefighters generally fall between the P5 and the P95 lines of the bust measurement of the general population, which means they have smaller variations. So this aligns with the results of our previous descriptive analysis. And the figure B, C, and D show the correlations between two measurements. Figure B visualizes the correlation between the bust and the waist. This relationship plays an important role in determining the dimensions of the upper body garment sizing system. So on the graph, we can see that the similar R values indicate that the correlation intensity for the female firefighters is similar to the general population. But as the equations of the regression lines shown below, the female firefighter has a smaller coefficient of the bust. This means that within our female firefighter sample, as the bust size increase, the waist size increase at a slower rate compared to the general population. In addition, our female firefighter data lacks representation in the smaller bust size compared to the general population. This is observed where the female firefighter data points have little overlap with the general population in the small bust and the waist area. It is around the intersection between the bust P5 and the waist P5 lines. And the figure C shows the correlation between the bust and the hip. This can be used to check the general relationship between the upper body and the lower body sizing, which is more applicable to a whole body garment development. We can see both data pools have strong and similar correlations between the bust and hip. But as the equations indicate, within the female firefighter group, as the bust size increase, the corresponding hip size increase at a slower rate compared to the general population. Also, our sample with the bust circumference measured around 90 to 100 centimeter in the female firefighter group have larger hips and have less variation in the hip size. And figure D shows the correlation between the hip and the waist. This is important for the lower body garment sizing system. The two data pools have similar R values, so this indicates they have similar correlation strengths. But the hip size of the female firefighter sample increased faster as the bust size increased. Also, our data lacks representation in a smaller hip size among the female firefighter group. And this supports our descriptive analysis for the hip circumference. To summarize our findings in the study, we found that the U.S. female firefighters are taller than the general population. The height difference is represented by the center back waist length, the front crotch length, and the leg inseam length. And U.S. female firefighters have waist and hip circumference significantly larger than those of the general population by 9 centimeter and 6 centimeter respectively. And such difference can be equivalent up to 2 pant sizes. And the U.S. female firefighters have bust circumference within the mainstream range of the general population, which is between the P5 and the P95, ranging from 85 centimeter to 141 centimeter. We didn't find statistically significant difference on average. But those two groups do have comparable total arm lengths. So to further summarize, the U.S. female firefighters in our study are taller, more uniformly shaped, and slightly larger in the lower body shape compared to the general female population. To conclude our answers to the two questions focused today, here are our answers. Is the current NFPA sizing system suited to the U.S. female firefighters. So for 1971, which is the standard for structure gear, it seems generally appropriate, but it definitely lacks many key measurements needed for the standard users to work with. In terms of the 1977, which is the wildland gear sizing, it clearly needs improvement and is less suitable in its current form. For question 2, can the body measurements of the general female population to be used to determine the gear size for the general population? We think the sizing for the general population may be a partial reference. However, it cannot be directly applied to develop the size for the U.S. female firefighters because of the significant difference between the two groups. And more importantly, the sizing depends not only on the range of the body measurements, but also on the grading rules between the size. These rules are grounded in the correlations among the accurately collected body measurements. Therefore, we recommend using the body data specific to the female firefighter population to address the gear sizing issues rather than relying on the data from the general female population. And here are the publications from our project up to date. If you have interest, you can do your own search, or we are very happy to share the document with you. Thank you to all of our study partners. Yeah. Thank you for listening to our presentation today. And here is our whole research team.
Many thanks, dear presenters, for this very thorough and practical presentations. So actually we have only 2 minutes until the end, but as you see already, maybe I hope we had a very tight traffic in our chat panel already, and listeners asking for presentations, and I see that you have sent already information, but maybe one question for Jemma. So where was asking about does this custom modification can weak also the protection of the garment? What do you think, Jemma? Can you hear us or?
Yes, I can
Yeah.
hear. So the question was whether the alterations to the garment weaken the protective performance. So that's essentially what we were trying to figure out with this study. It really depends on the modification, and the nature of NFPA 1970 is such that it really is looking at the material performance as opposed to how the design characteristics impact the safety. But from what we've seen, given that firefighters are introducing new types of materials, these new types of materials, if they're not heat stable or fire resistant, would create a safety concern. But there's kind of this balance that needs to be made, because at the same time, poorly fitted gear also creates many safety concerns for the wearer. So they kind of have to choose between being poorly protected with gear that doesn't fit them well, or trying to improve the fit, but opening themselves up to liability by moving away from the standard materials that are used in the gear.
Good, thank you for Jemma. And maybe for Dr. Qiu, I have a question, because there was the question about which kind of software you used or your scanner used. I did not notice. Did you give the answer already?
Yeah, we mentioned for collecting the female firefighter body data, we use the software called Me360. It's a scanning app by SizeStream, and the body measurements is automatically generated after we collect a scan.
Okay, thank you. So also there was questions, are those clothes tailored or customized based on the average of the measurements? So can you comment somehow?
What was the question?
So are those clothes tailored or customized based on the average of the measurements?
Based on average measurements.
Based on average measurements, yeah.
Yes, those are mean values. When we did the scatter plots, we use individual data points. So those points that you see are individual data points. However, when we do the correlation analysis, we use mean values. So it's a mix of both.
Okay, thank you. But maybe from my side, one question. So what do you think could like 3D body scanning and 3D designing of clothes can help and give like more practical solution to improve fit?
Yeah, definitely. We agree with that. Yeah. Just for just as you can see, the technology we are using for the body measurement is a remote scanning app, which is slightly more innovative compared to the traditional stationary body scanner. So we are still on the way of exploring using the exact shape we got from the scanning app, because that's not guaranteed to be correct, right? Yeah, but I agree we should involve the 3D shape to look closely into the fit more than the sizing.
I think it both plays a role in terms of the body measures and as well the 3D. Like Jackqee said, we have just gotten to the point where we're trying to look at the shape and how that informs design. In terms of sizing, you can have the perfect design and it still doesn't fit right if the size is wrong. So I think it's a bit of everything. It's a bit of complicated. In terms of 3D, everything can look perfect in a 3D computer system. And then when you go into actual garment production, something's off. So I think that's the place where we're being really careful. But, as Jackqee said, we've begun to look at that. In terms of the reliability of the data, we've done analysis, which is under review right now with the publishing house, is to see the agreement between the remote data scanning, the stationary scanning, and the hand measurements, right? And the difference between the stationary and the hand scanning and the app is that it's not location bound. We're able to, anybody anywhere can input into this database, which is awesome. But we need the three of them to agree. And what we've seen is a high agreement between the three systems. There is a bit of challenges when it comes to hand measurements, because experience matters. Who is doing the hand measurement? When you go to fire department, sometimes the person who is doing hand measurement has no idea what the body parts is or what the garment should look like. So that's also a challenge in itself. But what we've seen in ours, because when we did our study, we try to take out a lot of those bias. We keep the hand measurements to one particular person in order to make it as reliable as possible. And so we've seen great agreement between the three ways we've done it. So, and that paper should be out soon. So fingers crossed, we can share those.
Yes, well, so thank you very much. We are a little over already with our seminar. I remember you that you can get and see the recorded event. It's available in our website from Monday, I think. Mm-hmm. And also, I would like to remind you that our next webinar is already 26th of May. And the presenter is Dr. Patricia Dolas. So welcome to listen our third webinar in May. And now, yeah, thank you very much and have a nice Friday evening.